So we've already seen that it's true when two events are independent, that the probability of one event given the other event is equal to the overall probability of the first event. Now, if we were in class, we would do a proof of this second quality of independent events, but basically if we have that proportionality in the table, it's also true that the probability of A and B is equal to the probability of A times the probability of B. So this is a second way to test for independence. If this statement is true, then the two events are independent or they're not impacting each other, and the table has that proportionality where kind of all those fractions going in the same direction are equal. So we'll try this type of test on the first question. This is once again the passed and failed, male and female. So we'll just fill in the rest of the table and then start to calculate those events. So for my totals, there are 62 people that passed, 41 people failed. There are 47 males that took the test and 56 females for a total of 103 people. So the first thing, and once again, this is guided. If we were in class, you'd have to kind of figure out what to use first. We're going to do the probability someone's female times the probability that someone passes. So female, if I look in my table, is 56 out of 103. And passes is 62 out of that 103. So we're going to type that in to get the actual decimal, and we're going to the nearest thousandth, and that that fraction is equal to 0.327. Now the other thing we need to compare it with, the probability of A and B, or both of them being true, is here. So female and passing, that number is 35, and that's also out of the total of 103. And that gives me an answer of 0.339. So these answers are pretty close together. Maybe with more people, they would end up balancing out, but for now they are not equal. So we're going to choose unequal from this pull-down menu. So the events are dependent. So what that means is if you know the gender of someone in this table, it changes the probability from the overall probability that someone passes. So they are dependent, they're impacting each other. So moving on to this last question, you'll see that we're checking female times probability that the person fails. And that's one point if you get into this in a future class. Basically, whatever I pick here, then that's the thing I check for the and probability. And it's also true with our givens. So if I start out with probability of B given A, when we were doing the other page, then I would have to check the probability of B. Okay, if I did probability of not B given A, I would have to check the probability of not B. Okay, and this is something else I realized I haven't shown you. This line above means not, okay, or the opposite. So once we get into these harder problems, you would start to use notation. A couple other things on notation. When we say and, okay, that's actually denoted by a symbol like this. So it's kind of like an N without a line on it. And then if we say or, if we wanted to do or, we would actually use a symbol like this between the two events. Oftentimes too, we start to use letters versus writing full words. So this starts to look a little bit more like algebra. I just wanted you to see that even though we're not doing that since you guys are home. So we'll start on this question. Probability of female times probability of fail. So first off, the female probability, and I'm going to fill out my table first. Okay, so now that I have my table filled out, the probability of female is 74 out of 185. The probability that someone fails is 80 out of 185. And if I typed in these two together, that would come out to 0.173. Then to check to see if it's equal to, we want to do the probability of female and failed. So that's 32 out of 185, which is also 0.173. So here we see that these two events, or these two probabilities, are equal. So the events are independent. And if we did any other test, if we did probability of male given past and compared it to probability of male, if we did any other of our independence tests, because of that symmetry that's in the table, any of those would end up being equal. So even though I've really tried to work to help you understand this concept of independence, basically what you're looking for is if the two things you're checking are equal, then the events are independent, or if the two events are, or the two probabilities are unequal, then the events are dependent or impacting each other in some way.